Hi y'all, I just wanted to take a couple of minutes because one class we kind of barely made it through this. The other one we rushed through and didn't really make it through but kind of did. And the other class, well, we didn't even get to this question. So I wanted to make sure that you saw one that was like this. Okay, so this again is an exponential function. It's an exponential because the x is in the exponent here. Alright, so that makes it an exponential function. So we have a basic idea of what it's going to look like. We talked about how if the base of the exponent is bigger than 1, that's going to be exponential growth. So we expect it to look like this, okay, where we get closer and closer to some number going this way, and then we get really, really big that way. Okay, if this number is less than 1 but bigger than 0, so a fraction between 0 and 1, then we expect it to be a decay, which goes down like that. Now again, it does go on and on forever in both directions. You can put any number in for x, and you're going to get a number out for y. But let's go ahead. At this point, we're going to try to graph this. Now, if we think about this as a transformation, okay, when we look at this, we see this is our base, our parent function, which is 3 to the x power. Now, this is what's going to cause some type of shifting or stretching, right? The number that's being added, subtracted, multiplied, divided. And here it's a minus 1. Now this minus 1 is being subtracted from the parent function of 3 to the x power. There's a difference between this, which is what we have, and this. You may remember when we did quadratics that a transformation where we're subtracting 1 from the x, that's directly from the x, that would be a shift to the right. The one that we're looking at now, though, is taking the whole parent function, 3 to the x, the exponential function, and then subtracting 1. And so what that is that is a shift. That was messy. Shift down. So we've got a shift down of 1. So that's what we can expect. Now a shift down of 1 is not going to affect the x values that I put in. It's just going to move it up or down. So when I create my table here, I'm still going to do x and y, and I'm still going to put in the same numbers. -2, -1, 0, 1, and 2. And so when I put those numbers in, it will be 3 to the -2 power minus 1. Now 3 to the -2 is 1 over 3 squared minus 1, which is 1 over 9 minus 1. And so that is -8 over 9. Then I got 3 to the -1 minus 1. So that's 1/3 minus 1, which is -2/3. I'm doing the fraction part quick. If you need practice on fractions, then maybe you ought to look at that. But here I'm just going to do it rather quickly. I've got 3 to the 0 minus 1. 3 to the 0, of course, is 1. So that's 0. And then I've got 3 to the first minus 1, which is 2 minus 1. Sorry, 3 minus 1. I was getting ahead of myself, so 2. And then 3 squared minus 1, which is 9 minus 1, which is 8. And so now I can plot each of those points. I can go to -2, and then -8/9, which is close to -1, but not quite. And then I can go to -1, -2/3, which again is pretty close. Oops, that's not what I wanted it to do, so about there. Then we can go to 0, 0. Then we can go to 1, 2, and then we can go to 2, 8. And you can see that we've got this really nice exponential graph right here. Okay, going on and on forever both directions. Now, hopefully you notice that the asymptote is not at 0 anymore because it actually crosses through 0. Well, that should make sense because the graph was shifted down 1. So where we would normally have for our parent function an asymptote at 0, it's now at -1. And so there's my asymptote at y equals -1. And so there you go. There's your graph. It's exactly like the graph would have looked like in the first place. It's just everything's been shifted down one space. All right, so I hope that's helpful in your homework tonight. Good luck.